Hi all, this is Abhishek. I work as a technical architect with a leading organization. I'm an expert in Microsoft .NET, Azure Platform as a Service Cloud, Artificial Intelligence, Intelligent Automation, and Machine Learning. And today we will discuss how to do natural language processing using Azure Machine Learning Studio. Till now, we have seen a lot of concepts in Azure Machine Learning Studio in my earlier videos, like sampling data, splitting data, joining two datasets, and cleansing data, and much more. Today, along with these modules that we learned earlier, we will also use few natural language processing modules and come up with a model that will help in performing natural language processing. Okay, so let's get started. So before we get started with the Azure Machine Learning Studio, let us try to understand what natural language processing is. Natural language processing facilitates human-machine communication using natural languages. What I mean by this is a software program will be able to understand and process human language. The software programs should be able to generate human language and communicate it back to the humans. This is what the goal of natural language processing is. Few of the use cases are sentiment analysis. The best example of a sentiment analysis is a Twitter analysis. So like we are having lot of tweets on a Twitter handle, and we can perform an analysis and can predict which are the positive tweets and which are the negative tweets. Few other applications are text prediction. We can filter spams in emails. Chatbots are nice examples of natural language processing. We have chatbots for Alexa, Siri, Google Assistant. These all are excellent example of few best chatbots that are available in the industry today, and so on. The list is long. Okay, let us try to understand few of the concepts that we'll be using in today's machine learning experiment. So whenever we are building any natural language processing module, so it's very important to process the text in the text corpus. And also we need to have a huge text corpus for better results, for the model to be more efficient. So what are the different processing activities we do? We try to remove the stop words. Stop words are list of common words like a and the, add, be, etc. that do not have much relevance while analyzing the text corpus. So they have to be removed. Lemmatization is an important concept in natural language processing. It's all about identifying the root word for a word, or rather they're called as lemma. For example, for buying bought buys, the lemma is buy. For did done doing, the lemma is do. For played plays playing, the lemma is play. So we need to identify the lemma of the words used, and this lemma should be used while doing a natural language processing. We try to remove the hyperlinks and emails because they do not have much relevance when we are building a natural language processing module, or rather like we are analyzing a sentence that has a hyperlink or an email. At times we need to remove or process parts of speech like nouns, verbs and adjectives. We need to remove duplicate characters and so on. So a lot of steps we do to process and prepare the data. Okay, there is another important concept called as n-grams. So what are n-grams? N-grams are continuous sequence of n number of letters in a text or n numbers of words in a sentence. When n is 1, then it is called unigram. When n is 2, it is called bigram. And when n is 3, then it is called trigram. So now let us try to understand what n-gram is with an example. Suppose we have a sentence, I love to eat chocolates daily. So the n-grams can be I love to, eat chocolates, and so on. And you can see if we are trying to pick up a unigram from this sentence, that can be a single word in the sentence like love, eat, daily, chocolates. Suppose we are trying to pick up bigram in the sentence, they can be I love to, eat chocolates. And suppose we are trying to pick up trigram in the sentence, then it can be I love to eat chocolates daily. That is three consecutive words in the sentence. So why we need n grams? Let's see with an example. Let us try to explore a use case where we need to do some text analytics or text analysis, or rather like text prediction is the right word to use. Suppose we need to predict or suggest the next word when user keys in loves to. So our model, what it will do is we have a chat window, and when the user is typing loves to, then the chat window should provide auto suggestion for the user for the next word that he can choose from. Okay, so let us try to build this model. And as I've earlier told, whenever we are building any natural language processing module, we need to have a corpus of text, or rather a huge corpus of text. Here we are using the corpus of text as shown here, like Mary loves to eat chocolate, Sam loves to drive car, no one loves to eat stale food, Ram sometimes loves to smoke at night. Okay, and from this corpus of text, let us apply trigrams and pick up trigrams as highlighted in the sentences. These are loves to. In the first sentence, Mary loves to eat chocolate. We can see the red highlighted words or the trigrams are loves to eat. The second sentence, loves to drive. Third sentence, loves to eat. And the fourth sentence, loves to smoke. And from here, if we see the probability of it coming after loves to is 50%, and probability of drive coming after loves to is 25%. In the same way, probability of smoke coming after loves to is 25%. So with this probability and using this trigram methodology, we can actually build our model to suggest it after when the user types in loves to. So it can be a suggestion for our use case. Okay. So now let us get into the Azure Machine Learning Studio and try to apply all these theoretical concepts that we discussed now. I already have a experiment ready in the Azure Machine Learning Studio, and I'll be using this to demonstrate natural language processing. Okay. So I'm using a IMDb text review dataset that I picked up from this site, UCI Machine Learning Repository. It has a lot of datasets available that you can pick up and apply Azure Machine Learning to it. Okay, so let's try to see what this dataset has. This dataset is basically a corpus of text. It has two columns, comment and sentiment. For each of the sentences in the comment column, we have a sentiment labeled as either 0 or 1. 0 refers to negative sentiment and 1 refers to positive sentiment. And also we have 5 missing values. So what we need to do? We need to clean up this dataset and remove these or weed out these missing values, and then we need to make this sentiment column as a categorical column. Okay, let's do that. The first thing, let's cleanse the missing data. So here you can see I have applied the clean missing data module, and I'm removing the rows for sentiment that are missing, or rather they have missing values. Okay, the next step is I'm using the edit metadata to change the sentiment column as a categorical column. Okay, now here in the group categorical values module, what I'm trying to do is I'm trying to define new labels for each of the values in the sentiment column. In the sentiment column we have 0 corresponding to negative and 1 corresponding to positive. That's the mapping I have done. If you see, for 1 I am naming it as positive, and for 0 I am naming it as negative. And here you can see we have three levels. That is, by default we'll be having a default level. If that is, if we do not have any of the values, like so here we have done a mapping for 1 as positive and 0 and negative. What if the sentiment column has some other value apart from 0 and 1? That will be labeled as default. But in our case we don't have, since we have already cleansed the dataset. Okay, let's see. Let me try to run the experiment and we can visualize the output of the group categorical values. Be patient. It's a lengthy experiment. It will take some time. Meanwhile, the experiment is running. Let me walk you through the other stuff. Okay, it has completed. Let me try to visualize the output of this group categorical values. And here you can see we have replaced the 0, 1 with positive and negative. And we don't have any missing values since we have already cleansed the dataset, and we have marked this as our categorical feature. Okay, all good till here. So the next step would be to pre-process the text. So what are the different pre-processing operations we do? So here we say that the dataset is an English dataset. Then we are removing the stop words. We are doing the lemmatization on the comment column. All this we are doing on the comment column. Then we are normalizing cases to lowercase. We are removing numbers. We are removing special characters. We are removing duplicate characters, and so on. We are removing email IDs, URLs. So all these actions we are performing so that we can have the text ready so that they can be analyzed while performing natural language processing. Okay. So once the pre-processing of the text is done, then what we do, we'll split the dataset. So part of the dataset, or rather 40% of the dataset, we will use to train our model, and 60% we'll use to test our model. As the next step, we'll try to prepare n-grams from each of the sentences. Okay. So for this, we use extract n-grams features from text. What it does is, first it builds a vocabulary of n-grams using which it will extract n-grams from each of the sentences in the text corpus, and then this extracted n-grams can be used further for natural language processing. Okay, so let's try to do a dive into this module. Here we do not have a vocabulary already. We are using the raw data out here that we have got from split data, and from here we need to extract the n-grams. So we need to build our vocabulary, hence I'm selecting create. If we already have a vocabulary in place, then we can use either read only. If we want to merge or update an existing vocabulary, we can use update or the merge options. Okay, so the next step is defining the n-gram size, and here we are using trigrams. So we are defining n-gram size as 3. One important point I would like to make is, when we are specifying 3 as n-gram size, then in that case we will have unigram, bigram and trigram being extracted. This is how this module is built. 3 doesn't mean that it will only extract the trigrams, it will also extract the unigram and the bigrams as well. Same, like suppose we are specifying 4, it will extract unigram, bigram, trigram as well as the 4 grams. Okay. The next important thing we need to do is we need to select a weighing function, and here I have used TF IDF weight. There are different options available, and each of these methods have some significance or other and would work better with some text corpus or other. As of now, I have selected TF IDF weight. Okay. So where was I? Yep. So I've selected the TF-IDF weight. The next important thing that I need to select is the minimum n-gram document absolute frequency. What it means is how many times the n-gram appears in the whole corpus of text. If I'm specifying 5, then the n-gram has to appear at least 5 times in the whole corpus to be eligible to get into the n-gram vocabulary. Okay. The next important thing we need to consider is the n-gram document ratio. It specifies how many sentences have this n-gram specified divided by the total number of sentences. If we are specifying as 1, then it suggests that the n-gram is present in all the sentences. Okay. Then we need to select the detect out of vocabulary rows. That means if there will be any rows that any n-grams or any rows that are not present in the n-gram vocabulary, that can be detected and not used, so we should not be using it. Then we are normalizing the n-grams. We are using the feature scoring method as the Pearson correlation. There are different scoring methods. So as of now I'm selecting Pearson correlation, but based on the text corpus these values can be changed to get a better result. So we need a desired result of 100 features, so that's what I've specified as 100. And when I've run this experiment, I can see that we have two outputs. One is the dataset and another is the vocabulary. Let's first see what the vocabulary looks like. And you can see we have the n-gram out here, and we have a document frequency and the inverse document frequency populated out here. And this vocabulary will help in extracting or preparing the n-grams from each of the sentences. And these are the n-grams that are prepared. You can see we have the comment sentiment, then we have the pre-processed comments, then the number of unique n-grams that have been picked up from each of the sentence. Then we have these n-gram vectors, you can see pre-process comment tell along with their probability of occurrence in the whole data set. For example, this particular word let has a probability of 66%, and you can see it has been deduced from this sentence. And when we are applying the natural language processing, we do not need this comment column, pre-process comment, and number of unique n-grams as well as the n-gram string. We just need this pre-processed comment vectors as well as the sentiment. So ideally you should be actually weeding out these columns. They're not needed. Comment, pre-processed comment, num unique n-grams, and n-gram strings, and perform the machine learning. Here I haven't done it, but you should consider to do it for a better result. Okay. So a part of the data from the split data we are using it to test our model. So here again, what we are doing, we are using the same n-gram vocabulary out here and applying the same vocabulary to the other 60% of the data set. So here you can see I have selected the vocabulary mode as read only, and other parameters are as it is. I do not need any kind of filter based feature selection, so I marked it as false. Okay. And I'm using the same vocabulary. And then I'm using the two class logistic regression for training the model. And here I have kept the values default. Do not get into all these values now. Like, don't worry about this L1, L2 regularizations and LGBS and all, BFGS and all. So we will see them in one of later videos when we talk about the uh, algorithms involved in Azure Machine Learning Studio. As of now, I have just used the default values. Then here we are training the model, and we are training it with sentiment, and now we are scoring the model. We are for scoring our model, so we are providing input both from the trained model and as well as the extract ngram features, and then we are evaluating it. Okay, and post evaluation, what we have seen is our model is has a AUC as 73.3% and a precision of 63.5%, or accuracy of 66.2%. It is somewhat an okay model, like, because we didn't have much of data. It was just 1000 data that we started with, and it is highly suggested that we should be having a huge corpus to get better and efficient results. Okay, so before we wind up, let me just revisit the settings of this ngram module, because this is the most important module that is being used in this whole experiment. So here we are using the vocabulary mode as create, ngram size as 3, case skip size as 0. Case skip size is nothing but how many characters that can differ in a word. For example, we are having computer, and if you are having the case skip size as 1, then we can call the computer as computer. So like CONPUTER will be considered identical as COMPUTER, and we have a one character that is varying, that is n. M or N, they are represented as the same thing, like COMPUTER. Instead of that, we are having CONNPUTER. So we are choosing a weighing function, then minimum word length, maximum word length, then minimum ngram document, maximum ngram document. Then we are using a filter based selection. We are using Pearson correlation, and most importantly, our target column is a sentiment column. Then we have number of desired features as 100, and the ngram module that we are using with the test dataset, we are using the vocabulary mode as read only, since we're using the existing vocabulary from that has been created in the previous ngram that had extracted that was used to extract the ngrams from the training dataset. Just have a look on different parameters I'm using. Okay, this is what I had planned for today. Hope you liked it. Feel free to reach out to me if you have any queries. Thanks for being patient. Thank you. Stay tuned. There will be a lot of exciting videos on Azure Machine Learning Studio coming up in my next videos. Thanks.